Hi everybody, welcome to my channel. This is Shubham, and today I will be showing you how we can develop a machine learning pipeline to predict individual medical costs with a high level of precision. So first of all, we will see how I implemented the data, cleaned it, prepared it, engineered it, then deployed the prediction process. So first of all, it's important to import all of the necessary libraries such as NumPy, Pandas, Seaborn, Matplotlib, warnings, etc. Then it's also important to load in your dataset. So this time we loaded in the dataset from Kaggle. So this is the insurance dataset. So most important thing we need to do in the beginning is make sure the data is clean. If not, clean it, categorize it, and such. So first of all, as you can see, we can see all the different columns. We can see how many nulls and non-nulls there are. So as you can see, we don't really have any nulls in this data set, so there is no need to get rid of any null values. We can also try to see other things about the data, such as the charges, the BMI, uh, and then there's also the test data set. So it's split into training and test. So for this process, we implemented an AutoML model called H2O. This actually trains and provides us with the best types of machine learning models to predict. So first of all, we also need to check the categories for it. So some columns such as sex, smoker, region, and children, these are category columns, meaning sex as in like male or female, smoker as in like yes or no, region, north, south, east, etc. Children, 1, 2, 3, 4. So it's important to make sure that these columns are actually categorized as a category, because sometimes AutoMLs like H2Os can't actually understand that, and they might take that as an integer, which does not truly make sense. And then to check that, we can also try doing H2O describe, which will show us what type of data set each of them are, as you can see. And then we will import H2O AutoML, and then also define targets and predictors. So targets are basically the prediction, the outcome we want, and predictors are basically the variables. As you can see, we trained Auto H2ML for 5 minutes, which is 300 seconds, and it gave us with these models. So the types of models that H2O gave us are stack ensembles, stack GBMs, XGBoost, and you can also see their metrics on the side. You can see their RMSE, MSE, MAE, and RMSLE, and mean residuals. So after training the model, it's important to try to make predictions using the test dataset. So we tried doing that, and as you can see over here, this is the prediction that we created. And then now we can do this, and for me personally, I submitted this into Kaggle since it was a hackathon interview. But you can also try doing different things with it. You can keep it for yourself, you can use it for future predictions, you can use it for forecasting and such. These types of information are very necessary for companies and organizations as they make big financial decisions based on these. And we also tried, since we also got the statistics of it over here, we're going to try different models to see if they do better. So this is called, so what this is this time we're going to do a little bit of feature engineering. So I created an interaction term called obese smoker. So this means, because right now the machine learning model only categorizes people as smoker, yes or no, obese, yes or no. But there's also a thing called a multiplier effect, because obese smokers are at a much higher rate to develop health issues compared to smokers and obese people individually. So letting the computer or letting the Auto HTML know that helps with actually creating a better outcome. So as you can see, we also implemented a recursive feature elimination using a gradient boosting estimator to rank feature importance. This allowed me to select only the important variables, removing the noise from the dataset. So over here, as you can see, we used XGBoost. This time we increased it to 10 minutes, and we used a little bit of, we excluded deep learning because deep learning is actually overkill for such a small data set. So over here, as you can see, we predicted with new tuned leader. And then we also submitted that. So now we can also check the distribution of the charges. So we used plotting to figure out the distribution of medical charges. As you can see over here, it's pushed to the left. So there's a lot of counts of charges that are below 10,000, I would say. And you can also see the correlation heat map to actually see which predictors are actually more important, and we can actually make a decision based on that. And we also did a categorical variable versus charges plot. So you can see charges by smoker, yes or no. Charges by region, so are there any correlation between the region? Charges by sex, are there any correlation between gender? We also did a BMI versus charges, which clearly shows that obese smoker is a powerful feature. So this is an important thing that we did in the feature engineering process, as you can see. And we can also see the feature importance of the tuned model. So over here, we ranked the importance of the features. That was the outcome of the gradient boosting machine. So as you can see, smokers are the highest, obese smoker the second, just smoker third, age is obese, BMI, children, region, etc. And you can also see that the learning curve was implemented, where model performance versus training iterations are done. As you can see, around 10 to 20 number of trees, the mean squared error drastically decreases. Anything after that is just a slight decrease. It could even be a little bit of overfitting. So the final performance is we were able to come up with a model that has an MSE of 1s, 10s, 100,000, 17 million, which is a very good number. And things like this can be implemented for future cases. So thank you for listening, and it was great talking.